This is geometry. We're working on angle, side angle, and angle, angle, side proofs on the second day. What we do first when we set up these proofs, we want to look at our given information and be sure it's labeled in our picture. So we notice that angle G has one tick mark on it, and angle B has one tick mark on it. If you like to color code those, you could. We both have a red angle. And then we also notice that segment CB is parallel to segment GA. They're parallel to each other. Parallel does not mean congruent. Just because two segments are parallel does not make them the same length. So that doesn't give us congruent segments, but it does give us a hint on what we're supposed to be looking for. If we have parallel lines, we're supposed to be looking for one of our four types of angles. And what we would see here would be a zigzag coming all the way through. You down the parallel line, up the transversal, and down the parallel line. You have your zigzag. That's the alternate interior angles. That creates these two angles right here. Those would have to be congruent. If the two lines are parallel, then I know alternate interior angles are congruent. Now what I notice is that I have two A's and I need a third bit of information. There are four ways that we prove triangles congruent. So if we have two A's, I know that I'm going to be using one of these last two methods down here. I'm either going to need to show that the parallel sides are congruent because it's between the two angles in one triangle, or I need to show that this side that's being shared in the middle is congruent. So you have two A's and the non-included side. And I think we would agree that by reflexive, we would be able to see that that third side is the congruent side. So the way that we would set this up, we would say that angle G is congruent to angle B. That's our given information. So right now I have a A. I have one of the angles already shown. The other bit of given information tells us that segment CB is parallel to segment GA. That's also under the given. So if you don't want to write given a second time, you don't have to. But that doesn't give us an angle or a side just being parallel. We have to talk about what is happening. And if we look at our little shortcuts, if parallel lines, then alternate interior angles are congruent. Yes, we know we have parallel lines. The given information told us so. So we have alternate interior angles that will be congruent, and we labeled those in our picture. So we know that angle GAC, the red, the two ticker, and this one up in the corner, has to be congruent to BCA. The reason those angles have to be congruent is because of those parallel lines. If parallel lines, then alternate interior angles congruent. You don't say if alternate interior angles, then congruent. That's not good enough. It has to be parallel. You must have parallel lines first. And our given said that. If comes earlier, then comes right now. So that is another A that we have. We have an angle, then we're going to talk about a third bit of information. Remember, there are 4 ways so far that we are proving triangles congruent. So our third bit of information we haven't talked about yet is that from the 2 ticker mark up to this corner is AC. So segment AC is congruent to segment from the 2 ticker down to the corner would be CA. In this case, we are switching the orders of the letters, but that is still a reflexive POC. Reflexive property of congruence. Because it is the same segment in both triangles, we know that that side has to be the same. So I have a red angle the same in both of them. I have a 2 ticker the same in both triangles. And both triangles have the non-included side congruent. So this happens that we have done our proof in the same order that we planned on, that we wanted to show our triangles congruent. It's not a requirement, but it does show some organization. So triangle GCA is congruent to triangle BAC, and that's because the order of the angles and the side is not between those angles. It is angle, angle, side congruence. Looking at our next example, if you notice, we're going to try to prove that MJN is congruent with NLM. These triangles are overlapping, so it could be very beneficial for you to draw the triangles separately. They don't have to be perfect, but you have N, then M, and J, and then we would have N, M, and L. If you draw them not overlapping, it's often easier to see what information you've been able to show. So JMN is this angle here. L and M would be this angle there. So they both have a 1 ticker. J and M, this one over here, that's going to be a different angle, so we'll label it with a different number of tick marks. And LMN, a different number of tick marks. So it looks like we have 2 A's. So by looking at our 4 ways so far that we have to prove triangles congruent, again, we're going to be down here working with 2 A's and the included side, or 2 A's and the non-included side. When we look at our separated triangles, we don't really know exactly what sides are congruent. But if you look up in the original picture, you'll see that this segment is shared between both of the triangles. So that is a reflexive property. So these 2 segments have to be the same. So what I see for sure is that JMN is congruent. That's an angle, by the way. Angle JMN is congruent to angle LNM. That was our given. A lot of times, people like to put the other given right with it. So I'll show you what happens when we do that. That is with the same given. It was all from the given, and that was written on our proof. Those are 2 A's. They are both angles that show in how we're going to prove the triangle is congruent. We also showed that MN, segment MN, 1 ticker to 2 ticker, has to be the 1 ticker to 2 ticker, M to N. So again, well, let's see, I did it backwards. So we'll go 1 ticker to 2 ticker, M to N. So NM for this one, NM. However it happens, we would typically write them in opposite orders because the triangles are reflections of each other. So that again was the reflexive POC. They are sharing the same side in the original picture, so that's how we know those two segments are the same. Now it looks like we proved the triangle is congruent using angle, side. That was the order in which we wrote out our proof. We did 2 angles and then we did a side. But notice in the original picture, that side is actually in between the angles. So just because it's written as angle, side doesn't mean that that is your final answer. It has to match what your picture is. And our picture shows that the S is in between the 2 A's. So it's angle, side, angle is the correct answer. And then our final example, it brings in a new method for us. Notice this upside down T. That's going to stand for perpendicular. That is perpendicular. So ST is perpendicular to TW. So the symbol we use is this little box in the corner. VW is perpendicular to WT. So we put the box in the corner. Angle VTW, we could put 1 tick mark on there if we like, is going to be congruent to SWT. So you follow your eyes from S to W to T. That middle letter is your vertex. So far, we have these boxes, which are going to eventually show that they're congruent, and the 1 tick marks, which from the given information. We also have the side that's being shared between the 2. So that's an easy one to recognize. We don't want to miss that one. Those are nice ones to have. That's the reflexive property. Now something we need to notice is if perpendicular, then right angles. That's the order that we have to go. Every time we talk about perpendicular, we want to talk then about right angles. So we're going to come in here and get our information in here. Let's see. Let's say that angle VTW is congruent to angle SWT. That was our given information. With our given information was also segment ST perpendicular to segment TW. We also had VW perpendicular to WT. That was all given information. So this first angle was up here. That was our A. Now the perpendicular tells us that angle STW and VWT are right angles. Some people think it's kind of silly to make that statement, but we can't get to congruent. We got to go through right. If perpendicular, then right angles. We've got to talk about right angles after we talk about perpendicular. And then, if right angles, then congruent angles. So we know that angle STW is congruent to angle VWT. So if right angle, then congruent angles. Our next step could be to show the reflexive property. And then we're ready to prove the triangle is congruent. And you got to use the picture to do that. Angle, side, angle.